Let's look at doing an example of finding the normal when x equals minus 2 of our equation g of x, which is equal to 1 over 3 x cubed minus 2x plus 2. Well, we're going to need our equation for the normal, which is given by y equals minus 1 over the derivative evaluated at that point, outside of x minus that point, plus the evaluation of the function at that point. So first of all, let's evaluate our function at that point. So we're going to solve when g of x is equal to x of minus 2. So we'll just plug that straight in. 1 over 3 stays, minus 2, we're going to cube that. We're going to have minus 2 outside of minus 2 plus 2. So looking at this, we're going to have minus 2 cubed. Well, 2 times 2 is 4. 4 times 2 is 8. Now we've got a negative, and then another negative, so we'll end up with a negative 8 over 3 minus, well, 2 times 2 is 4. Minus and a minus is going to be a positive, so that changes to a positive 4, and then we'll have a plus 2. Now let's simplify this part. 4 plus 2 is equal to 6. This part here is over 3, so we're going to have to times this by 3. 6 times 3 is 18. And we'll just divide that by 3. Is going to give us our 6, which remains the same. So we add this in. We get minus 8 over 3 plus 18 over 3. Minus 8 plus 18 is going to give us 10 over 3. So now we've solved when our g of minus 2 is going to be equal to 10 over 3. So next step, we need to look at finding the derivative. So our rules for a derivative are when we have a function as a polynomial with kx to the n, our derivative is kn x to the n minus 1. So our g prime of x is going to be given by 1 over 3. Now the 3 comes down, so we'll end up with a 3x to the 3 minus 1 is 2, minus our 2 stays, so that becomes 2. Our 1 comes down, so it's times by 1. So let's try and find our g prime of x. Well, that's going to be equal to, our 1/3 stays, but we bring the 3 down, so it becomes 1 over 3 times 3x to the, well, 3 minus 1 is going to be 2, minus our 2 here stays, so we get 2x is just x to the 1, so it becomes x to the 0, which is equal to 1, so we just leave that off. And the 2 has no component of x, so we don't include that in the derivative. So simplifying this, our 3 times 1/3, well, that's just going to be 3 over 3, which is equal to 1, so it just becomes x squared minus 2. Now we need to evaluate this at our point, so our g prime at minus 2 is going to be equal to minus 2 squared minus 2. Minus 2 times minus 2 is going to be 4. So it's going to give 4 minus 2, which is going to give us 2. So now we have our derivative and our function value at that point. So now we can just put it into our equation. So our equation gives y is equal to minus 1 over our derivative, which was 10 over 3. Then we just put in our x minus 2, so that becomes a plus 2. Close the bracket. And then we put in our function value, which was 2, so it's just plus 2 at the end. First thing we should do is simplify this fraction. So putting that, the very bottom goes to the very top, so we get minus 3 over 10 outside of x plus 2 plus 2. Now we can just expand and simplify it. So we get minus 3 over 10x plus 2 times 3 is 6. So then we get minus 6 over 10 plus 2. So we have a negative and a positive. We'll just change those so it's just a single negative. Because our 3 here is divided by 10 and our 6 is divided by 10, what we're going to do is times both sides by 10. So we'll end up with 10y is equal to minus 3x minus 6. Because we've timed everything through by 10, that 2 needs to also be times by 10. So 10 times 2 is 20. Now we can just simplify our minus 6 plus 20 is going to give us plus 14. So 10y is equal to minus 3x plus 14. And that's going to be our equation for our normal at the point when x is equal to minus 2. So now let's have a look at this on a graph. Our orange line here is our original function g of x, 1/3 x cubed minus 2x plus 2. And our purple line here is our equation for the normal, which is given by 10y equals minus 3x plus 14. But that is only the equation of the normal at the point when x equals minus 2, at that point up there.